In this video, we'll be learning on how to convert number lines into set builder notation and interval notation. Let's start off with this problem. So we have a number line right here. And what we're going to do is draw the interval notation for it first. So whenever you have a shaded endpoint, this means x can be exactly this value that it's at. And we use brackets whenever we have a shaded endpoint for interval notation. Hollow point means x cannot equal that value. And we use parentheses to denote that. So we have a hollow point at 2. So that means we use parentheses. Since x cannot be exactly 2, there's a hole in the number line. So x can't be exactly 2. And then we have 7. 7 has a shaded endpoint. X can be exactly 7. So we use a bracket there. So that's your interval notation. Now the last thing we have to do is create the set builder notation for it. So x is going to be the shaded in region right here. This is going to be x. So x is going to be in between 2 and 7. So all we have to do is determine the signs. So for your hollow point, that means x cannot be that exact value. But notice that x is to the right of 2. So x is greater than 2. But it cannot be equal to 2. So it's just going to be x is greater than 2. No equal to sign on the bottom of the greater than symbol, since x cannot be exactly 2. So for 7, we have a shaded endpoint, and we have x is to the left of 7. So x is less than 7. But we have a shaded endpoint, so that means x can be exactly 7 as well. So we have to include the equal to part. So x is less than or equal to 7. And that's your answer. Now, what about this number line? How do we write this in interval notation? So we have 5 and 7, where x is going to be in between. Remember, x is the shaded in region in between the number line. So at 5, we have a shaded endpoint, so x can be exactly 5. So we use a bracket to represent that. And the same goes with 7. 7 has a shaded endpoint, so we use brackets there as well. And that's your interval notation. Now, for your set builder notation, x is going to be in between 5 and 7. So x can be exactly 5, but notice that x is to the right of 5, so x is greater than 5. And x can also equal 5 because we have that shaded endpoint. So x is going to be greater than or equal to 5. Then we have 7. X is to the left of 7, so x is going to be less than 7. But it has a shaded endpoint, so it can also be equal to 7. So it's going to be less than or equal to 7. And that's your answer. Now we have our number line. So anytime you have an arrow pointing to the right direction, it's going to be positive infinity. If the arrow is pointing to the left, it's going to be negative infinity. So let's draw this in interval notation. So we have 4 and positive infinity, where x is going to be in between. So 4 has a hollow point, so that means x cannot be exactly 4. So we have to use parentheses there. And anytime we have infinities, whether that's positive or negative, you have to always use parentheses. The reason why is because infinity is a concept. It doesn't have a direct numeric value for infinity. Like, we know that 4 is 4, but infinity can be any type of number because it goes on forever. So since you know that x can't be exactly a numeric value for infinity, you use a parentheses. So that's why. Now, all we have to do is draw the set builder notation. So we have 4, x, and infinity, because x is going to be in between 4 and infinity. So anytime you have infinity in your set builder notation, you don't want to use it, because I'll show you why. So let's erase the infinity, and let's just do 4 and x. So we have 4 and x. So for 4, we have a hollow point. So x can't be exactly that value. So no equal to part. But x is greater than 4 because it's to the right of 4. So we have to use a greater than symbol. Now, if you look at this inequality, 4 is less than x, or x is greater than 4, however you look at it. If x is 5, it is true. Now, the same goes with infinity, because 4 is less than x goes to positive infinity. So it's already incorporated in that inequality. So that's why we erase the infinity in our set builder notation, just to simplify it. So that's why. And that's your answer.